Hi everyone. In this video, we are continuing section 3.1. In the last video, we learned that probability is favorable outcomes divided by total outcomes. Now, we are going to apply that idea to a standard deck of cards. Before we calculate anything, let's review what is in a standard deck. A standard deck has 52 cards. There are 4 suits. The suits are heart, diamond, club, and spade. Each suit has 13 cards. The face cards are Jack, Queen, and King. Be careful here. In this case, the face cards are Jack, Queen, and King only. The ace card is not being counted as a face card. This is a common mistake. Let's look at example 3. A card is randomly selected from a standard deck. So when you select a card from a standard deck, the total number of outcomes is 52. Question A, find the probability of drawing a 5. Let's use the probability formula. Probability equals favorable outcomes divided by total outcomes. The number of total outcomes is 52. Now, we need to find the favorable outcomes. Our event is drawing a 5. How many 5s are there in a deck of cards? 1, 2, 3, 4. There are 4 5s. So the number of favorable outcomes is 4. Probability of drawing a 5 is 4 out of 52. And the question asks for reduced fraction. So I need to reduce 4 out of 52 to 1 over 13. Question B. Find the probability of drawing a face card. Remember, the face cards are Jack, Queen, and King. So how many face cards are there in a deck of cards? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The number of favorable outcomes is 12. I use the same formula. The probability equals the number of favorable outcomes divided by the total number of outcomes. In this case, the total number of outcomes is 52, and the number of favorable outcomes is the number of face cards, which is 12. The probability of drawing a face card is 12 over 52. Now, let's simplify this fraction. Both 12 and 52 are divisible by 4. So we divide 12 by 4 and divide 52 by 4. We get 3 over 13. Question C. Find the probability of not drawing a heart. My event is not drawing a heart. To find the probability of not drawing a heart, we use the same formula. We take the number of favorable outcomes divided by the number of total outcomes. Here is our deck of cards. We have 4 suits and 13 cards in each suit. These are 13 heart cards, and we don't want them. We want these cards, and these cards, because we do not want a hard card. There are 39 cards that are not hard. So the number of favorable outcomes is 39. And the number of total outcomes is still 52. Now we need to simplify this fraction. Both 39 and 52 are divisible by 13. So we'll divide 39 by 13 and divide 52 by 13. We get 3 over 4. So the probability of not drawing a heart is 3 over 4. Now, let's move on to the next idea, complements. The complement of an event is the event not happening. So if the event is drawing a heart, the complement is not drawing a heart. If the event is rolling an even number, the complement is not rolling an even number. If the event is drawing a face card, then the complement is not drawing a face card. And we use a bar on top of the event to represent the complement. So when you see an event with a bar on top, that means we're talking about the complement of that event. So the probability of the complement of A equals 1 minus the probability of A. This works because the event happening and the event not happening must add up to 1. In other words, something either happens or it does not happen. Together, those cover all possibilities. So let's connect this to an example. Find the probability that a randomly selected card that is not a face card. From the previous example, we found the probability of drawing a face card was 3 over 13. Now, we want the probability of the complement of that. So, using the complement rule, the probability of not drawing a face card equals 1 minus the probability of drawing a face card. So this event is a complement of this event. The probability of drawing a face card was found in the previous example, which is 3 over 13. So we'll replace this probability with 3 over 13. In order to subtract fractions, we need common denominator. So we'll rewrite 1 as 13 over 13. And 13 over 13 minus 3 over 13 is 10 over 13. The probability of not drawing a face card is 10 over 13. And I leave it as a reduced fraction because the question asks for it.